Okay, I will start off now. Welcome once again, and thank you to all of you for joining us on this Walterman webinar series. The topic of today's webinar is specifying of fire-rated cables and associated issues. My name is Shekhar Prince. I am the marketing manager for Nexans Olex, and I am joined by my colleague Hilary Marizzato, who is the technical director for Nexans Olex. Unfortunately, due to a sore throat issue, I will cover only the introductory slides of this webinar and hand it over to my colleague Hilary, who will take you through the rest of the webinar. We will conclude with a Q&A session at the end. If you have any questions, please feel free to send them to us during the webinar via the dialog box located at the bottom left-hand corner of your screen. If we are unable to address your questions today, we will revert back to you with an answer post the webinar. With that, I move into the second page, or the second slide. The agenda, this is the outline of the topics that we are intending to cover today. To start with, we will cover terms that are commonly used in the electrical industry where it is implied or inferred that the customer is inquiring about a fire-resistant cable. So that's the first part of this webinar. We will then go into deconstructing the terms of reference that are used to understand what is the difference between those terms and what do they actually mean. For the sake of simplicity, we will refer to them as fire performance properties of cables. We will then go into those fire properties and applicable standards, test methods, as each of these terms commonly used mean a different type of cable. The difference between the standards that are commonly referenced when specifying these types of cables, and how do the performance standards or the test methods differ. Finally, we'll conclude with looking into a solution of how we can use common terminology as an appropriate nomenclature to specify these fire-rated cables. So to start off things, I've just put up a slide there which covers the terms that are commonly used for electrical cables when people are discussing the term fire-rated cables or fire-resistant cables. You can see that there's 6 or 7 different types of terminologies that are used. Circuit integrity cable being the most commonly used. You have 2R fire-rated cable, low smoke zero halogen or LSZH fire-rated cable, FR cable, fire retardant cable, low smoke zero halogen fire retardant cable. Now these are a lot of terms, but not all of them mean the same thing. And I've certainly spoken amongst the knowledgeable people on the subject. We have found that not all people use the terms to mean the same thing, so this leads us into the discussion of deconstructing this into simpler parts. I believe, or I think all of us may have come across some of these terms, or may have used some of these terms when discussing the topic of fire-rated cables. So I'll move into the next slide. Now, I guess in order to understand, this concept of fire-rated cables, we've just put up a few questions there, which is, what is flame retardant cable? What is low smoke zero halogen cable? What is fire-resistant, fire-rated? What is circuit integrity? And what is an FR cable? If you may notice that the bottom 4 are in a certain color, the red color. The above 2 are in a different color. Now, again, from the colors we draw the reference that it's implied that the ones in the same color actually mean the same thing, and the other 2 cables are different. So it is important to demystify and clearly understand this terminology, how the interrelationship works between these terms. We will see during the presentation, and perhaps some of you know the answers already, but we encourage you to stay and see what else we have to show you. With that, I will hand it over to my colleague Hilary Marizzato, who will take it from here. Thank you.
Good afternoon, and I'm Hilary. let's start with the next slide, which covers flame retardant cable. Such a cable is designed to only restrict the spread of fire by inhibiting combustion of the cable itself. It doesn't mean that the cable will not catch fire, and if there is a high energy fire, the cable will not only catch fire but will continue to burn. But once the energy source is removed, it will self-extinguish and will not by itself propagate the fire. The cable thus aims to retard the spread of fire. The solution is to use appropriate materials, and I suggest to you that cable materials do react in different ways to fire, so be aware that these materials have a varied flame retardant or a varied flame propagation property. On this page we introduce the standards applicable. These tests are not used to compare and rate materials from best to worst. They just tell us whether the material retards fire and flames for a specified distance along a cable. PVC is a compound of a number of ingredients, and it can be formulated to have good retardant properties up to being an excellent flame retardant material. The low smoke zero halogen materials, also compounds, need to include the right materials in the right quantities and give good to excellent properties. On the next page we see the chambers where the tests are performed. These tests are to establish the flame propagation in a vertical arrangement. Now these are two separate tests, and it may seem from the pictures that the chambers are similar in size, but that's not so. For the chamber on the left, the testing is for a vertical 600mm piece of cable, and the chamber is 1200mm high. It tests if the cable will burn upwards and if burning material falls off. The time the flame is applied is 1 minute on cables less than 25mm diameter, and increases with the size of the cable, so that over 75mm diameter the flame is applied for 8 minutes. The chamber on the right has 3.5 metre lengths of cables mounted on a vertical ladder, so this chamber is much larger. Here we must comply with the requirement of having a nominated volume of burnable materials. So it can be a single large cable, but with smaller products we may need to mount on the tray 10, 15 or 20 smaller cables to achieve the volume required. Now a category A test has the highest volume requirement, and a category C has the lowest volume requirement. There's a burner at the bottom of the chamber, and this particular test, the fire and flames must not rise any further than 2.5 metres. On this slide we're looking at what is the low smoke zero halogen cable we've mentioned a couple of times. The fumes from these materials when the material is burnt does not contain halogens, and you see a chart on the right of the screen showing the chemical list of the halogen materials, starting with F for fluorine, Cl for chlorine, then bromine, iodine and astatine. The halogens are flame retardant, and that's why they've been used in cables, but they have the side effect of generating high volumes of black smoke and acidic fumes. When we say PVC, the C stands for chlorine. So PVC has the halogen, and under combustion it gives off some hydrochloric acid, which is very corrosive. The solution is to specify halogen-free cables and not just chlorine-free, which has happened. The tests and standards are again given, and we list some material and cable types that are low smoke and halogen free. The questions you should be concerned with are in the red box at the bottom of the screen. These pictures show the test apparatus for the smoke and the halogen content of materials. The smoke chamber on the left is a 3-meter cube, and the test is done by burning a cable piece, then looking through the window and checking if you can see to the other side. With PVC, you cannot see the other side. The test on the right is just a chemical laboratory type test and looks for the ingredients of the material once it's burnt. Now we get to fire resistant. Within the context that this means cables that can maintain circuit integrity while subject to a fire. That's what we take it to mean. There are many applications where this property is required, and we've listed some here. The difference for the cable itself is that the insulation or the protective layers need to be capable of holding working voltage while at the elevated temperatures of a fire. Now, amongst the listed standards here, you see the introduction of a new standard. This is the AS/NZS 3013. You haven't seen that before on this presentation. And its title is Electrical Installations, Classification of the Fire and Mechanical Performance of Wiring System Elements. Now, it's not like the earlier standards which address the cable itself or the properties of the materials used in cables. The AS/NZS 3013 is for the testing and classification of elements in a wiring system so that the whole system may perform as required. The testing takes place one element at a time, but the key criteria is that the furnace is controlled so to follow a specified time temperature curve. I understand this curve attempts to represent a typical fire in a building with a mixture of burnable materials. The time temperature curve is taken from AS 1530.4 and from ISO 834. And because of this test, AS/NZS 3013 has been referenced in a number of building standards, and more importantly, it is referenced in the Building Code of Australia, and the cable classification is nominated for specific applications. Looking at the note in the red box, please note that in making these products, Nexans Olex has chosen to include many of the features we've talked about, all in the one range of products. It seems to me that other cable manufacturers have made a similar decision. This is the test apparatus for the 1660 Part 5 and 331. It has a single cable directly subjected to fire from a burner. The cable is not shown on the picture on the right, but it is fixed in a U shape with the two ends at the top of this supporting frame with the electrical connections, and the bottom piece there is the burner. In the case of 3013, it's quite different. In order to give the time temperature curve, the test is performed in a furnace. Cables are on a normal tray installed up near the lid of the furnace, and they're installed with two 90-degree bends. On the right here you see the lid of the furnace being removed after a 2-hour test. At that point the temperature of the tray and cables will be 1000 degrees, or about 1000 degrees. So the term fire-rated, we wanted to highlight that we get the request often. I want a fire-rated product, but this term is not really good enough. There are many ways of getting a fire-rated cable, and we've listed some here. Plus, the tests that we would use to classify this include a range of variations. So we need to describe more clearly what is really wanted. And do we have a solution for that? Yes, we do. First, I think we need more of this type of discussion to disseminate the knowledge. And I suggest that reference can be made to an additional standard. Again, we haven't introduced yet. Here it is, AS 4507, Its title is Cables, Classification of Characteristics when Exposed to a Fire. It was issued in 2006 for exactly the same reason that we're doing this webinar now. It covers the topics we've raised and short discussion we've had on them. Key thing is that it ties together the performance required with a classification and the appropriate test and standard that applies. It contains 3 new terms, new because we haven't introduced them yet. RFP, so they've changed the words a little bit, and that means reduced flame propagation. RHE is for reduced hazardous effects, so that one's for the acidity, smoke, and etc. And CI for circuit integrity. This is a reprinted, retyped chart that comes out of 4507. In the columns, there are various classifications of cables, and in the rows are the various tests. So if you were to select, let's say at the 3rd column, the RFP3, you would get a product that meets the flame propagation as a single cable, and you would get a flame propagation category A test. If you pick one of the others across, wherever there's a tick, that would be the test that is performed on the cable that you purchase. So this allows a classification of 9 combinations of properties, and it provides a quick term that gives you what you need. And this classification relates to cable properties. Now, I've mentioned the AS/NZS 3013, and because that's more than just a cable test and it's a classification of a complete wiring system, it's not included in this table. If you were to apply it to cables only as a component of the system, the 3013 would be a CI option. It tests for circuit integrity. This standard here, the 4507, is intended for these classifications to be marked on the cable surface so they can be easily identified. And as I mentioned, these classifications can be easily specified. The specifier could potentially reduce a lot of the details in describing what's required by just nominating this one 4507 classification. An alternate use of the 4507 is to present a table somewhat like this. On the left-hand side is different cable types, and of course the Nexans Olex cable types that I've put there. And in the columns are various properties, and in the final column you could have a 4507 classification that then relates to that particular product type. So such a chart would assist in identifying the 4507 classification for each product and enables the classification in a contract specification, for example. Now, we've gone through this presentation quite quickly, but that's it. That's what we have for you today. I'll mention that we do plan to do more webinars with detailed topics, as we see quite a lot more issues that come about from addressing this topic. Now, if I can request you to please complete the short 4-question feedback survey, it would be greatly appreciated. I would like to ask you if you have any questions. Now would be a good time to put them. I haven't seen any come through. I'll give you a moment to think and type them up. We're having some issues with our buttons here. I have a question here about, do fire-rated cables carry more current than the standard XLPE? It's not really a function of the fact that it's a fire-rated cable. It's a function of the capacity of that insulating material to take or to support a higher temperature or lower temperature and not be damaged or be prematurely aged by running at the higher temperature. It has been typical that for fire-rated cables there is additional materials put in there that tend to enable it to run at a higher temperature. So being able to run at a higher temperature means we can put more current into that conductor and get a higher current rating. I'm looking for another question. I have a question, it related to 3013, about who actually makes the test in the 3013 chamber furnace, whether it's the cable manufacturer or the manufacturer of the cable tray. Good question. The setup that I showed with the chamber, with the tray and cable on it is specific to testing the cable. And so we have wires attached to the cable ends. We check the integrity while the 2-hour or 1-hour fire test is performed. In the case of testing a tray, I believe that the main criteria there is to test the tray with a specific weight of cables on it, and to test its capacity to hold that weight while under fire. So that's performed in a different manner. So the test I've shown you is performed by the cable manufacturer. The test on trays is performed by the tray manufacturer. And if you were in a position where you were trying to confirm compliance, you would have to do two separate tests, one on the cable and one on the trays themselves. Another question, is there an XLPE cable that is 2-hour fire rated? Yes, there is. The XLPE itself as an insulation isn't 2-hour fire rated, but by having another layer in the cable, the XLPE during the test would burn off. The other layer would need to remain. It provides the voltage control, the voltage insulation, and therefore you get your 2-hour rating. Any other one?
That's it. How do we download it?
There's a question about downloading the presentation. It will be available on the Voltimum website within a couple of days or next week. I'm getting nodding by my colleagues here. So it will be available, and I believe it will be available with the text as well, with the video, yep, and the soundtrack. Okay, so thank you very much.
Any final questions?
Any further questions? It seems not. Thank you very much. Good evening to you all.